Welcome everyone to Project Management Fundamentals for February 2022. This is about how projects succeed. This Project Management Learning Series is about improving your project management skill sets and developing the successful skills to be able to manage high quality solutions delivery and being able to do that within budget while navigating the complex barriers that come with federal government projects. And we do this through talking about real-world examples of what we've done in our projects and the lessons that we've learned through those projects and the combined experience that we've gained through a wide portfolio of projects across the federal government. So for today's agenda, we're going to start with introducing the team making this presentation. And then we're going to talk about 3 different case studies. First is going to be the General Services Administration. The second is going to be a project from the Health Resources Service Administration. And finally, we're going to conclude with a project from NASA. And then we'll wrap things up with our lessons learned, the takeaways from this presentation, and useful knowledge that you can take with you for your next project. So first, let me begin by introducing myself. My name is Michael Iams. I'm an enterprise architect with REI. I have almost 20 years experience working with a wide variety of federal agencies, including the General Services Administration, NASA, FEMA, USCIS. My principal focus is on the areas of cloud architecture and as well as DevSecOps, which is about automating software development and delivery. Next, I'd like to introduce Kim.
Hi, I'm Kimberly Farrell, and I'm an Agile Certified Practitioner, also with over 20 years of experience providing typical program, project manager, performance, cost, scope, schedule, all while serving as a contractor within the various HHS agencies. I'm honored to be with you today as we dive deeper into understanding the factors that can contribute to projects not meeting desired outcomes. Okay, on this slide, you can see there are some basic ingredients that make up a project. What's needed? What do we want? What's desired? What are the aspirations? Defining the what of a project. The next is who. Who are the people that will benefit from this project? Who are the people leading the project? Who are the people who are engaged in delivering the project? Next, there's technology, or the how the project will be executed. Overlying all 3 of these is the process that serves to connect the first 3 ingredients. Last, we need to document and write down those ingredients so it's clearly understood by all using something like a contract, a statement of work, a statement of objectives, performance work statement. These are all our shall statements. But sometimes, even if we have all the right ingredients, a project doesn't always turn out quite right. Have you ever made a cake that didn't really taste like you expected, or substituted a single ingredient and you no longer had a cake at all? Well, that same thing can happen in our projects. Let's take a couple of minutes and think about why they fail. First, often it's scope creep. The project started with a defined scope, then it went along, features were added, features modified, new items added, and none of them were even refined to the existing items. Next, competing priorities. Program leads need key features to meet program needs. Technical features that also must become must-haves. No one can prioritize one feature over another. So that leads us to the next one. Stakeholders want it all within the same budget and same schedule. Therein, before you know it, estimations are way out of alignment with those expectations. At the start of the project, it all seemed achievable. Well, at least on paper. Everyone begins working without really taking the time to identify the risk that exists for this project. If it's a multi-year project, what could impact our success? If it's 12 months or less, the same. What's the impact to the scope? Often there's poor communication. Who knows what's really going on with the project? What's the time commitment for the stakeholders? How do you keep everyone informed of decisions and key milestones that must be met? This leads to a lack of visibility. How is progress monitored and measured? So let's take a look at our 3 case studies of projects that didn't quite succeed as originally planned and what lessons were learned. Over to you, Michael, for the first case study from GSA.
Thank you, Kim. So for this first project, this is an IT modernization for a large multi-module transaction-based system. It's a public-facing application, so we have a wide variety of users, including the general public, federal civilian workers from the federal, state, and local agencies. This was a large modernization project spanning over 18 months in length, and we were modernizing a mainframe-based application. So this is an application that hadn't been really meaningfully modernized in 20, 30 years at least. And it was the previous application was actually multiple separate applications, and part of this modernization was bringing those up into a common user interface. Part of this is we wanted to use features as the existing legacy system. So we weren't trying to redo things and re-engineer it. We wanted to keep the same processes in place. Again, trying to keep the user feel the same, just as with a modernized user interface. And the program requirements came from the program objectives. So these are defined by law, as well as the policies and procedures within the General Services Administration. Notably, we did not go back and analyze the legacy system that's running on the mainframe system to kind of decompress that in terms of its components. Instead, we went to the original program as a way of understanding those requirements. So what were some of the challenges that we faced? First, ensuring that the proposed solution is meeting all of the requirements that the government has, and that there's a shared understanding of those requirements. As everyone in the government knows, the RFQ process is very concise in terms of specifying requirements for a particular contract. Sometimes work that may take months and months may be defined as a sentence or two in an RFQ, and the response from the vendor may only be a paragraph. Sometimes that requires much more detailed analysis that can only be done after post-award. Next, we want to make sure that there's a mutual understanding among all of the stakeholders. With large systems, there's usually multiple sets of stakeholders involved, each having their own view on the requirements of the system and what it needs to accomplish its tasks. And so we need to make sure that there's a mutual understanding among all of them for their requirements. Ensuring automated testing. So with modern software development practices, we want to make sure that automated testing is used to facilitate efficient software delivery, as well as ensuring the quality of the software. But there are inherent challenges that come with automated testing, because if the underlying code is changing or the structure of the code is changing as the process moves along, the tests themselves have to be rewritten. And process. We're now using software delivery as the default process for IT software modernization processes. A fundamental component of that is the user accepted testing, or UATs. And these are absolutely essential because they provide the timely feedback for the developers to know that they are actually producing the results with the expectations of the government in mind, that they're the government's expectations. And this is a process that holds both the developers accountable for making delivery of those actual functionality in the ways the government expects, and the government is also accountable to making sure that it is signing off that yes, we've looked at these features and they're approved, and now the development team can go on to the next set of features without having to worry about kind of coming back later on after the fact and changing things after the fact. And with all large projects, the development and infrastructure need to be integrated. And as development moves along, the requirements may change or become more described in more detail later on. And so the infrastructure has to be able to migrate in parallel with that shared vision. And this is naturally able to do with the cloud capabilities of today, but it does need to have a constant attention. And finally, security is very important. This particularly went well with this project as GSA was debuting a new process that was a true DevSecOps type of process where they embedded GSA security personnel into the development infrastructure team. They were part of weekly Scrum sessions, and so there was sort of a constant communication between the security team in terms of the requirements to get an authorization to operate and the development team. And this made sure that, at least from the security standpoint, everything went very well. We were on schedule for that delivery. So what were some of the lessons that we learned with this project? One is it's best to have, after the kickoff, the project kickoff, to have a more detailed deep dive session of the project requirements with the government, and being able to spend the time to do the deep dive of the analysis of those requirements up front. Because sometimes these may take several weeks for a business analyst to dive deep into those requirements, get the necessary information, and come back. But this is all vital information for project schedule management and planning. Second, again, we're talking with large projects, getting stakeholder buy-in. As we talked about before, there's usually multiple stakeholders involved in these types of projects, each with their own particular interests. And so we need to make sure that they all have buy-in to the proposed solution. And this also applies on the development teams as well. With these large complex applications, we want to make sure that developers have a comprehensive understanding of the entire application, not particular elements of this of the application as they work on individual functionalities or subroutines. Third is stabilization of the requirements. With Agile, we know that requirements change, and we want to be able to push things off to the last possible moment before we actually have to finalize those decisions. And basically, we'll get with the benefit of the previous UAT sessions in terms of getting out the requirements and the expectations of the business community. But it's also important that once those requirements are set, that we're not going to keep going back and revising them later on. And this is pivotal to the development of automated testing. These are referred to as non-functional requirements, and so we don't want to have to keep going back and rewriting code for those automated tests, as it would just be inefficient process. And next, we want to make sure that stakeholders are meaningfully engaged in these UAT sessions. As we've mentioned before, these are vital to the process, and it's a challenge for government personnel to be able to devote enough time to these UAT sessions. They often have multiple competing needs on their time, and they're subject matter experts. But this is really their opportunity to get their feedback and actually see that feedback reflect itself back in the application. They ask for a particular feature or a workflow, and within the next sprint or two, they can actually see that come to life in an actual program. And so their feedback on these UAT sessions is really important. Next, I'd like to bring back Kim to talk about HRSA.
Thanks, Michael. Okay, so for our case study for HRSA, it started in 2009. A performance reporting system was integrated into HRSA's electronic handbooks, or also called EHBs. This is a critical part of the grant lifecycle for the uniform data collection. All public health centers receiving grants funding through HRSA must submit their performance data into this module. This data is required for compliance with legislative mandates, reporting program accomplishments, and justification for budgets. Additionally, the system provides aggregated data for reporting and decision-making. Currently, in UDS, there are more than 300,000 lines of code, 2,500 business validations, and 900 analytical measures. So you can understand the complexity within this module itself. Then it's integrated into the EHB's platform for additional features and functions. EHB's has over 17,000 registered organizations and 45,000 active users. Adding to the complexity for UDS is also multiple stakeholder groups beyond the health centers. There is the HRSA program office, the Office for Quality Improvement, there are universities and other contractors who all play a key role with the annual reporting and review cycle. So Let's jump forward 8 years later to 2017. So with changes in the program needs and improved technology, HRSA embarked on a large-scale system modernization. They wanted to leverage the new tools and enhance system usability. Due to the nature of the annual reporting cycle and to remain within the various budget constraints, it was decided to follow a multi-year phased approach. So, as you can tell, this is a highly visible system used frequently with zero downtime. So the risk tolerance within this project is extremely, extremely low. Basically, it must remain perfect, always reliable, and never fail. So the final phase of this project will release this year in 2022, and I can tell you it has definitely had several challenges. So let's talk about those. So first, in a 5-year modernization project, that's a really long timeline. The return on the investment is not readily apparent to the stakeholders and system users. There have been changes in project leadership, changes in key stakeholders from those that provided the original requirements and objectives. Second, due to the complexity of this system, technology became the driver for what was prioritized as features that needed to be implemented. The business need often became secondary or was moved to a lower priority. Also, as data analytical tools, machine learning, and AI have increased in sophistication, there's become more of a focus to harness this technology for greater insights into such a vast amount of data collected in the system. So, the focus no longer remained as it was defined at the outset of the project. A third challenge has always been the increasing list of system enhancements. As new enhancements were introduced, enhancements to the enhancements were now added to the backlog for implementation. So what have we learned from this? First, we needed to implement frequent, regular, and multi-channel stakeholder communication to review progress and obtain guidance on the feature development. It's critical to keep everyone engaged and invested in the success of the project. We held sessions to review accomplishments, next steps, and confirm that everyone agrees with the project goal and the path to reach that goal. Next, we needed constant backlog review with a focus on the feature prioritization based on business value. It wasn't necessarily a focus on the latest and greatest technological tool that was on the market. It required collaboration between both the program leadership and the technologist supporting the project. And third, while it's really fulfilling for users to use the system and get excited about using it and envision even greater capabilities, i.e. adding more enhancements to the backlog, we do hold frequent discussions on the definition of done. What does this mean? What is our shared understanding of this meaning? For software projects, development can actually be limitless. It can be and should be continuously improved, but given the constraints of schedule, budget, and scope, they must be confined. Schedule and budget, scope must be confined by these two parameters. Okay, now for our last case study, NASA. Back to you, Michael.
Thank you, Kim. So this last case study is a project within NASA called the Small Business Innovative Research Application Program. Every government agency that has a research and development budget is required by Congress to set aside a certain percentage of that budget for small businesses. So this is a project that's managed through the Small Business Administration, and this is the solution for the NASA, and it involves a 5-phase process of application development in terms of what is the need of the agency in terms of innovative research, what are their requirements. Essentially, it's a catalog of things that they're looking for. People make their proposals. These are usually research scientists with some new innovative technology or process, and that then has to be reviewed by government agencies, usually subject matter experts within NASA. Then contracts are awarded, and finally the contracts are managed. For the SBIR project, it's a 3-phase award process with progressively incrementing larger amounts of contract awards as the technology matures. REI has been providing this service for NASA for over 30 years. And in fact, we were an SBIR awardee with our first proposal for this contract, in which case we took this from a paper-based project to an electronic-based project. And over that time, the scope of our responsibilities has increased greatly. So not only are we responsible for the technology of the program, but we also support the program office, as well as change management. We provide help desk functions, outreach and communications, which is very important because we need to engage with the community to encourage maximum participation in terms of proposal submissions. So we have outreach in conferences across the country, seminars, those types of things. And we also provide strategic advisory functions for the program. This first phase was rolled out in 1991, and then approximately every 10 years, the technology has been refreshed, and most recently in 2018. And as with most large government programs, you have to deal with leadership changes. And with NASA, it's been no exception. In 1991, we had the space shuttle was the primary technology, and the space station was the primary objective. Since that time, studies of Earth observations and climate change became very important. Then going to the moon and going to Mars, all those priorities have changed over time. And understanding the unique business needs and the technology drivers to make that accessible. So what were some of the challenges that we faced within NASA? Well, one was as leadership changed, there would be new program drivers and objectives that they're trying to achieve, and they couldn't necessarily understand what was the decision-making process for previous technology choices. Second, NASA is a very leading edge agency. They want to make their sites very much similar and follow the best practices of commercial sites such as Amazon and Facebook. But there's inherent challenges for the federal government to be able to do those types of things. Privacy concerns, regulations, all of those can be challenging trying to bring that same sort of user experience to the federal government. Contracts is an ongoing challenge. As we talked about, this is a three-phase approach, and these contract requirements have frequently changed, and sometimes within the program itself, there's changes within the objectives of the contracts. And so for the contract process itself to be able to keep up with those changes, it can be a challenge. In addition, agile software delivery has become the standard for software development processes. And it's been difficult for contracts to adjust their deliverables, their processes to align with agile software delivery. And next, we've had this shift from just reporting data itself and making reports to actually gaining insights from the data. And this is using some of the AI and machine learning information, but we need to tailor those data insights to the many different stakeholders. So for SBIR, there's needs to report to Congress, but also we need to report to the Small Business Administration, as well as NASA itself, the project managers across the 10 different data centers. They want to see how their investments in the SBIR project are doing in terms of their particular objectives. So all of those have different types of data insights that they're trying to get, and we need to be able to tailor those. So what were some of the lessons that we've learned along the way? First, it's important to provide a well-framed documentation of the technology trade-offs that are made. And normally we do this, but it's made within the mindset of the current set of people that you're talking with. Everybody already knows the context of what the challenges are and what the possible solutions are and such. But this was more about making this documentation available for the next generation to come in afterwards, so that they can see what were the trade-offs that you made and why did you make those, and given in light of new technology drivers that may not have been apparent at this time. Second is investing in end users and stakeholders. Essentially, we want to be able to pull back the curtain for these stakeholders in terms of what was the design thinking and the service design processes that led to the development of the user experience that they're seeing. There's an architecture to this, and it's helpful for them to understand the underlying architectural elements so that they can then fully appreciate the integrated design choices that were made. And third is this shift to agile development teams and pods, cross-functional teams. And this is to be as responsive to the program needs and the technology changes as possible. So we want to be able to quickly be able to move a team that was working on one program or sub function to another because the priority for that changed. And so the teams need to be cross-functional so that they have automated testing built into the team. They have quality testing, development, user experience, and requirements capabilities all within that team, and that makes them much more portable and responsive to the needs. So next, what does all this mean? What are some of the things that we get? Kim, what do you think?
Yeah, so we heard a lot about what our challenges are and how the lessons were. So we're thinking, what's the few key elements we took from our experiences that we feel will help lead to a success? So first, customer experience. That is really paramount. The focus in a project is not only on the technology. Technology is used to support the customer experience. Next was change management. It should be prioritized throughout the project. We all know the sooner all the stakeholders are involved, aware of the change, and can plan for the change, the better the outcome will be. Next, it's critical to establish a shared vision between all the stakeholders. What does done look like? Does everyone have the same expectation for success? Next, you should spend time at the start of the project to understand and document the customer journey when they're using that system. Should it be changed? What are the pain points? You can get a lot of valuable insights when you look through the customer journey. And last, there must be a frequent feedback loop for continuous improvement. This is really critical for multi-year projects. You need to use retrospectives, check-ins, etc., to confirm that the needs are still being met. Don't forget, users, technology, and tools all change. So on our last slide, we're going to leave you with a little quote from Henry Ford that says, "The only real mistake is the one from which we learn nothing." So when you face those challenges and you see them as challenges, you can learn from those. And then that will help enhance you on the next step in the next project that you lead. Thank you.